Hello, everyone. We are working through statistical methods for rates and proportions, chapter 4, section 4.3. Now, this section in our book talks a lot about using tables to be able to calculate the power and the given sample sizes. And what I'm going to do here is just use R to do the same thing. So from the last video, we did a plot given a particular P1, P2, alpha, and beta. And what I'm going to do is I'm going to add on to this function so that I can output the values and take a look at them. So once again, we're going to calculate Q2 and Q1, P bar, Q bar from the formulas in the book, alpha over 2. We'll get our Z alpha over 2. We'll get our Z beta. We'll calculate N prime based on the formulas. We'll get N. From there, we will plot our N and our power. But now I'm going to add a few more lines that gives us the values of N, beta, the power, and then I'm going to tack on the alpha level, the value of P1, the value of P2, and at the end of the day, I'm going to ask R to just tell me what all those values are. So this new function does a lot of what the last function did from section 4.2, but it's also going to give us the values for lots of different values of beta. So if I want to, I can get the sample size table that has all of this information by using my new function that's called get.plot.values. So I'm going to do the example where the first proportion is 0.6. The second proportion is 0.5. Our alpha level is 0.05. And we have a sequence of betas between 0 and 1. All right, this table is very long. So I'm just going to look at the 20th to 50th value. So here I get the plot. It's very similar to the last plot that we saw. And we can see that the sample size for each group, right, is 664. That corresponds to a beta of 0.049, a power of 0.951, the alpha level was 0.05, the proportion was 1 was 0.6, and the proportion 2 was 0.5. Or similarly, we could say, where do we achieve 98% power? So 0.98. I would need a sample size of 814 for each group. My beta would be 0.02, same alpha level, same P1 and same P2. But this is nice because this function, we didn't have to recalculate every single time that we changed our beta. We could also easily change our alpha level and get all the values very quickly just by setting alpha to be 0.01 rather than 0.05. As you can see here, our power curves changed based on the different alpha level. And we can see to achieve 98% power with alpha being 0.01, we need 991 individuals per group. Okay, if we wanted to look at a particular value of beta, rather than looking at the whole table, I could just say, just tell me the answers for beta equals 0.05, power equals 0.95, beta equals 0.25, the power would equal 0.75. So now it just tells me the two values. At 95% power, I need 827 people for each group. And at 75% power, I need 500 patients per group. Another way to pick off these values would just be to say, hey, give me the rows where the power equals 0.95. Give me the rows where the power equals 0.75. Give me the rows where I'd have 300 patients per group. These three values would give me the answers that I'm looking for. Okay. Next, we're moving on to example 4.32. And what we're going to do is in this example, P1 was 0.7, P2 was 0.85, alpha level of 0.05. We're looking at all the different beta values. We're using our built-in function. And then I'm going to just look at the values where my number of subjects is bigger than 100 and smaller than 200. By running this, I can see that the power in this situation is going to be from 67% up to 93%. Example 4.3.4. We have P1 is 0.05 and P2 is 0.15, alpha level of 0.05. We can run the same function. We can then look at the table when we have between 100 and 200 patients. And in this case, we have that the power ranges from 0.57 up to 0.88. Right, how does that compare to when we switch our alpha level to 0.10? Right, we can see that our power went up. Right, the alpha level goes up. In this case, for the same sample sizes, we see that the power also increases. We also see that the type 2 error decreases. So for this situation, you can easily compare what happens when you change your sample sizes and when you change your alpha levels, how that affects your power. So running through a few examples can help you understand the relationship between alpha, beta, and power. Hope you learned a lot in this video, and I'll see you next time.